Have you ever imagined something so powerful that it bends time, warps space, and shoots out beams of energy at nearly the speed of light? Welcome to the enigmatic world of black holes. The cosmic titans that don't just swallow everything in sight, but sometimes, astonishingly, spew out colossal jets of energy that race across galaxies. These jets, traveling at mind-bending speeds, are among the most mysterious and spectacular phenomena in the universe. But why do black holes, known for their voracious appetite, shoot out light-speed jets? Today, we are about to unravel one of the universe's most stunning paradoxes. To understand this cosmic conundrum, we first need to picture a black hole not as a simple void, but as an extreme laboratory of physics. Imagine a whirlpool in a river, only infinitely dense, infinitely deep, and invisible, pulling in everything that strays too close, including light itself. The boundary around a black hole, known as the event horizon, marks the point of no return. Once crossed, nothing comes back. But paradoxically, some black holes don't just consume. They launch streams of particles and radiation into intergalactic space at nearly light speed. How can something that traps everything also release something so violent and luminous? The answer lies in the fascinating interplay between gravity, magnetism, and spinning matter. Black holes themselves are deceptively simple. They are defined by just a few properties: mass, spin, and charge. That's it. No surface, no internal organs, just a singularity hidden by the event horizon. But simplicity is deceptive. Surrounding many black holes is an accretion disk, a swirling, glowing pancake of gas, dust, and stellar debris spiraling toward the abyss. As matter falls in, it doesn't plunge straight down. Instead, it orbits the black hole. Friction and immense gravitational forces heat it to extreme temperatures, often tens of millions of degrees, causing it to radiate vast amounts of light, particularly in X-rays. The accretion disk becomes a cosmic furnace, a violent, spinning engine fueled by gravity itself. Here's where the story becomes electrifying. When a black hole spins, it drags space-time around with it in a phenomenon known as frame dragging, predicted by Einstein's theory of general relativity. Picture a spinning egg yolk within a spinning bowl. Everything close to the yolk is forced to move along with it. In the case of black holes, this creates incredible conditions for magnetic fields, which are already embedded in the infalling matter. These magnetic fields are stretched, twisted, and amplified by the whirling disk of plasma. They become the invisible rails along which charged particles can be accelerated to astonishing speeds, forming what scientists call relativistic jets. Now, let's visualize a jet. Imagine a cosmic lighthouse beaming a column of charged particles across the vast emptiness of space, brighter than entire galaxies, traveling at 99.9% the speed of light. These jets are astonishingly narrow, like a garden hose squeezed until only a thin stream of water emerges, but can extend over hundreds of thousands, even millions, of light years. They punch through the interstellar medium, heating gas, triggering star formation, and shaping the evolution of galaxies. In essence, a black hole isn't just a destructive force. It's a cosmic sculptor, influencing everything around it through these incredible beams. You might be wondering what exactly accelerates these particles to near-light speed. This is where the genius of nature's engineering comes into play. The spinning black hole stores rotational energy, which can be tapped by magnetic fields in a process known as the Blandford-Znajek mechanism, named after the astrophysicists who first described it. Think of it like winding a cosmic dynamo. The faster the black hole spins, the more energy is available to launch particles outward. Matter spiraling in the accretion disk interacts with these fields, creating conditions similar to a particle accelerator, only on scales that dwarf anything humanity could ever build. Unlike earthly accelerators that push protons along straight paths, black hole jets are guided by twisted, magnetic highways that extend far beyond the galaxy itself. But not all black holes produce jets. Scientists have observed that only certain black holes, particularly those spinning rapidly and surrounded by dense, magnetized accretion disks, launch these spectacular outflows. The angle, strength of the magnetic fields, and the properties of the infalling matter all determine whether a jet will form. It's a delicate cosmic choreography. One misstep and the black hole remains silent, devouring quietly without fanfare. Observationally, these jets are a treasure trove of information. Astronomers detect them across the electromagnetic spectrum, from radio waves to X-rays and even gamma rays. By studying their emission, scientists can infer the speed, composition, and magnetic structure of these streams. Some jets carry massive amounts of energy, equivalent to the output of trillions of suns, across distances that make our Milky Way look like a tiny speck. They can impact star formation rates in their host galaxies, regulate the growth of the black hole itself, and even heat intergalactic gas, preventing it from collapsing into new stars. In other words, these jets are not mere side effects. They are fundamental agents of cosmic evolution. Let's pause and consider the scale for a moment. The energy released in a single black hole jet can outshine the combined light of all the stars in a galaxy. Imagine a lighthouse so powerful that it can be seen across billions of light years, guiding and shaping the fate of entire galactic neighborhoods. And yet, despite their incredible luminosity, the engine driving these jets, the black hole itself, remains invisible, hidden behind the curtain of the event horizon. It's a paradox that continues to intrigue and challenge scientists. Interestingly, the fastest jets appear to be launched by the most extreme black holes, the supermassive giants at the centers of galaxies. These titans, weighing millions to billions of times the mass of our Sun, are cosmic dynamos. Some, like the one in the galaxy M87, have jets extending over 5,000 light-years, and recent observations by the Event Horizon Telescope even image the base of the jet, revealing the connection between the black hole's spin and the outflowing material. These observations not only confirm decades-old theoretical predictions, but also open a window into physics under conditions impossible to replicate on Earth. There's another twist to this cosmic story. Black hole jets are not uniform. They flicker, bend, and precess, almost like a cosmic heartbeat. These instabilities are influenced by changes in the accretion disk, interactions with surrounding gas, and magnetic turbulence. Some jets even emit mysterious high-energy bursts, which may be linked to magnetic reconnection events where twisted field lines snap and release tremendous energy. Picture a cosmic version of a solar flare, but millions of times more energetic, capable of launching particles across entire galaxies. Each flicker, each burst is a message from the black hole, offering a glimpse into the extreme physics at play. Now consider the implications. These light-speed jets are not just spectacular, they influence the cosmos itself. By injecting energy into the surrounding medium, jets regulate the growth of galaxies, control star formation, and shape the distribution of matter on cosmic scales. In some cases, they can prevent galaxies from collapsing into dense, star-packed regions, acting as cosmic thermostats. Essentially, black holes, often depicted as mere destroyers, are crucial architects of the universe, their jets serving as tools to sculpt cosmic structures over billions of years. And yet, despite all we know, many questions remain. How exactly do black holes convert rotational energy into these focused jets with such efficiency? What determines the exact composition of these streams? Is it electrons, protons, or more exotic particles? Could there be a connection between these jets and mysterious phenomena like fast radio bursts or high-energy cosmic rays? Every discovery seems to reveal new layers of complexity, reminding us that black holes, despite being objects of intense study, are still among the most enigmatic entities in the cosmos. Imagine standing on a distant planet, looking up at the sky. Somewhere, a supermassive black hole spins, invisible to the eye, yet launching a beam of energy so intense it could outshine the entire Milky Way. That lightspeed jet travels millions of light years, influencing the formation of stars, the growth of galaxies, and even the evolution of cosmic structures. The universe, in all its grandeur, is interconnected in ways we are only beginning to understand. Black holes, paradoxically both destroyers and creators, exemplify the sublime power and mystery of the cosmos. So, why do black holes shoot out light-speed jets? Because in the extreme environment of a spinning magnetized accretion disk, matter and energy are channeled along magnetic highways, accelerated by gravity and frame dragging, and ejected into space with astonishing efficiency. These jets are a direct expression of the black hole's rotation and magnetic field, a spectacular paradox of cosmic physics, where destruction and creation go hand in hand. They remind us that the universe is not just a collection of objects, but a dynamic, interconnected system, full of surprises, contradictions, and awe-inspiring phenomena. Next time you gaze at the night sky, remember that somewhere, far beyond the reach of our eyes, black holes are not just consuming. They are sending beams of light and energy across the cosmos, shaping the universe in ways we are only beginning to grasp. These jets are not just beautiful, they are a testament to the power, mystery, and elegance of the laws of physics. If this cosmic journey fascinated you, don't forget to like this video, share it with fellow space enthusiasts, and subscribe to Cosmic Horizon Hub for more deep dives into the wonders of the universe. And tell us in the comments, if you could ride along one of these lightspeed jets, where in the universe would you want to go? The cosmos is vast, mysterious, and endlessly surprising. Black holes remind us that even in the darkest corners of space, there is extraordinary power, light, and motion. And here at Cosmic Horizon Hub, we'll continue to explore, question, and marvel at these cosmic wonders, one mind-blowing phenomenon at a time.